All right, 7.2, systems of linear equations, this time in 3 variables. Okay, so if you think about this with an x, a y, and a z, that's at least the most common variables we use. We're now 3-dimensional, and we're trying to figure out where all 3 lines might cross at the exact same point, okay? So, some hints as we do this. We need to reduce our system to 2 equations with 2 variables. So we have to use every equation at least once. We can use one more than once, but each equation must be used at least once, and we have to have the same goal of eliminating the same variable each time so that we can move our systems down and work with our new 2 variable systems, okay? So use all 3 systems or equations once and do the same job with when we eliminate something, okay? And this is primarily always the elimination method because we have so many, you can't really substitute in with the other one. We could, but not as easily, okay? So I look at my 3 equations. Thankfully, they're all in the same form with the x's, then the y's, then the z's, then the equal, then the constant. So that's good. Does it look easier to get rid of x's, y's, or z's? There's no wrong answer. I'm going to go for the y's, okay? So the first thing I'm going to do is I'm going to decide that I'm going to eliminate all y's, okay? Make sure you know your goal and make sure that's where you're going for, okay? Because that's going to be part of the key is keeping straight which variable you're doing. So the first time, I'm just going to take equation 1 and I'm going to add it to equation 2. And because they're already lined up to eliminate. So x plus 3x is 4x. Negative y plus y cancels. 3z plus negative 2z is plus z. And 8 plus negative 2 is 6. Okay, so I used equation 1 and I used equation 2. I must use equation 3 this time, and I have a 4y. So I'm going to choose to take my equation 1 and multiply by 4, and then add it to equation 3. And that means that I'll have used every equation at least once. So on my top equation, 4 times x is 4x. 4 times negative y is negative 4y. 4 times 3z is 12z. And 4 times 8 is 32. You have to multiply everything in there by that number, not just the term you want. I'm going to put it with equation 3, which is 2x plus 4y plus 4z equals 0. And I'm going to add my 2 equations together. That gives me 6x, my y's cancel, gives me 16z equals 32. All right, so now I have 3 times 4, right? Okay, I'm just checking something here because I wrote something that I didn't need. Let me see, right here. This was not 4z. I don't know where I got 4z. This was z. Okay, and so this one is 13z. Okay, that's better. Need to be careful. All right, now I have this system of equations. I have a 6x plus 13z equals 32, and I have a 4x plus z equals 6. Okay, these are the 2 equations I got after eliminating the y's out of all the equations. Now I have a new system. I can either substitute or eliminate. My natural instinct is to always, you know what, I'm gonna substitute, even though I like to eliminate, because this z is so close to being by itself. I'm gonna make it negative 4x plus 6. And I'm gonna take this and I'm gonna replace it into this z. So that gives me 6x plus 13 times that expression, negative 4x plus 6 equals 32. Distributing, I get 6x minus 52. Does that sound right? 52x. Plus 1878 equals 32. All right, that will give me a negative 46x. I'm going to subtract 78 to the other side, which good, gives me negative 46. At least I don't get a decimal or a fraction. And I get x equals 1. Okay, that's 1. I'm going to substitute it back in over here. So z is going to be negative 4 times 1 plus 6. Negative 4 plus 6 is 2, so z equals 2. I need my y. I can plug it into any one of those first ones. I'm going to go up to the very top one. X minus y plus 3z equals 8. All right, I know my x is 1. I don't know my y. My z I found was 2. All right, I get 1 minus y plus 6 equals 8. I get negative y plus 7 equals 8. So subtract my 7, divide by negative 1, and I get y equals negative 1. So my ordered triple this time, the x is 1, the y is negative 1, and my z is 2. And again, just like we did on our 7.1, you can always replace it, plug it back into the equations and double check. On my first equation, that'd give me 1 plus 1 is 2, plus 6 is 8. It works for the first one. On the second equation, I'm going to get 3 minus 1, which is 2, minus 4, which is negative 2. It works. On my third equation, 2 minus 4 is negative 2, plus 2 is 0. It works for all three, so we're looking good for this system. All right, number 2, example 2. Find the quadratic function y equals ax squared plus bx plus c whose graph passes through the given points. All right, something different here, but this is something I'm going to tell you right now. I go to over and over in PreCalc because to be able to take points from a graph and take it into and write the equation for the function is a big deal. So I may do this to you a lot in different times. So it's important to know how to turn these points into a systems of equations. Okay, so remember, this value here is an x and this is a y. So I take this form of y equals ax squared plus bx plus c, okay? And in for every x in this equation, I'm going to plug in negative 2, and in for every y, I'm going to plug in 7. So I get 7 equals a times negative 2 squared plus b times negative 2 plus c. Okay, when I do the math there, I'm going to get 7 equals 4a minus 2b plus c. Okay, that's equation 1. For equation 2, for every x, I'm plugging in a 1, and for every y, I'm plugging in negative 2. So I get negative 2 equals a times 1 squared plus b times 1 plus c. And that gives me the equation negative 2 equals a plus b plus c. All right, for my third equation, I plug in 2 for every x and 3 for the y. So the y gets a 3, a times my x of 2 squared plus b times my 2 plus c, which gives me the equation 3 equals 4a plus 2b plus c. I have a system of equations. I'm not using x, y, and z. I'm using a, b, and c, but I still have a system. All right, here's our job. Do we want to eliminate my a's, my b's, or my c's? I'm going to go for my c's, okay? Anybody's choice. You can choose anything. I'm going to choose to eliminate my c. So I'm just going to write that note so you know what my work has, but, okay, you can always change that. Okay, so what I'm going to do is I'm going to do equation 1 minus equation 2, if you can handle that, because I don't, due to space, I'm going to try not to rewrite, okay? So if I take 7 minus negative 2, I'm going to get 9. 4a minus a, I get 3a. Negative 2b minus b, I'm going to get negative 3b. C minus c is gone. Okay, I've got to use equation 3 this time. I'm going to, you know what, because it was easy enough, I'm going to do equation 1 again minus equation 3. Because again, as long as I use a different equation, and I have to use equation 3 this time. Okay, so I'm going to do 7 minus 3 is 4. 4a minus 4a, interesting, it disappears. Negative 2b minus 2b is negative 4b. And c minus c cancels. Okay. I actually got a free b this time around. Because I got rid of 2 variables on that bottom equation, I can solve for b right now, and I can divide by negative 4, and b equals negative 1. So I kind of lucked out, and it helped me that I didn't have to go, that I was already done with that, okay? Now, I can just plug it back into my other short equation right there. 9 equals 3a minus 3 times negative 1. So 3a plus 3 equals 9. Subtract 3, I get 6 equals 3a, and I get a equals 2. All right, I have one more to find, and that's c. Any equation will work. Because I just have been working with the top, I'm going to work with it. 7 equals 4 times a, which is 2. minus 2 times b, which is negative 1, plus c. All right, 7 equals 8 plus 2 plus c. So that's 10 plus c equals 7. Subtract 7, or 10, and I get c equals negative 3. Okay. I have my my variables. I could write it as a triple, but this wasn't to solve a system. It said to find the quadratic function that matches this equation. So what I found is the coefficients into my equation. So y equals, my a is 2, so it's going to be 2x squared. My b was negative 1, so negative x. My c is negative 3. This is the parabola, or the function, that had all three of those points on it. And we just found the equation of that parabola, okay, using a system of equations. All right, one more example here. It says, at a college production of Streetcar Named Desire, 400 tickets were sold. The ticket prices were $8, $10, and $12, and the total income from the ticket sales was $3,700. How many tickets of each were sold? The combined numbers of $8 and $10 tickets sold were 7 times the number of $12 tickets sold. Okay. We need equations, we need variables. So I'm going to call X is going to be my $8 tickets, Y is going to be my $10 tickets, and Z is going to be my $12 tickets. Okay. Once again, like we did yesterday in the 7.1, we want a quantity equation. So my X tickets plus my Y tickets plus my Z tickets equals 400 tickets. That's my quantity. Now I'm going to go my money, okay? So 8 times X plus 10 times Y plus 12 times Z made me $3,700. Okay, the third equation, they gave us kind of this rule. The combined number of 8 and 10 tickets sold, so X plus Y, was, that's my equal sign, 7 times the number of 12, so 7 times the Z. Okay, there's my three equations. I'm going to set them up a little bit different. So X plus Y plus Z equals 400. 8X plus 10Y plus 12Z equals 3,700. And then this bottom one, X plus Y minus 7Z equals 0 when I move everything there. Okay, we need to make a choice. What do we want to eliminate? I don't know. You want to eliminate, I would say, like, the X's or the Y's look the easiest to eliminate, is what I'm seeing right now. Okay, so maybe I'll go for the X's, okay? So make a choice, right? I'm going to eliminate X. I'm writing it down so I don't forget, so I don't lose track of what I'm doing. So my first thing I'm going to do is I'm going to do equation 1 minus equation 3. Okay, so X minus X gives me 0. Y minus Y, oh, this is really going to work out fine. Y minus Y equals 0. Z minus 7Z is 8Z. 400 minus 0 is 400. And I guess right away I divide by 8 and Z equals 50. Okay, that actually worked out better than I thought at first, but we'll go from there. Okay, I'm still going to work on eliminating X out of that equation too. Okay, that's what I want to do. So knowing that, I have to use equation 2. I'm actually going to multiply the top equation by negative, you know what, I'm going to do the bottom equation because those numbers are smaller. Negative 8 times equation 3 and add it to equation 2. So on my bottom equation, I get negative 8x minus 8y plus 56z equals 0. And then I'm going to add it to my equation 2, which is 8x plus 10y plus 12z equals 3,700, right? Can't read my writing. My x's eliminate. I get 2y. I get plus 68z equals 3,700. And now what's super nice is because I already know what z is, I can come plug it in. 2y plus 68 times 50. I really hope I did my math right there. I guess I'll find out shortly, huh? 68 times 50. 2y plus 3,400 equals 3,700. So 2y equals 300, and y equals 150. I think I'm good. Okay. And that leaves me with one to go, which is my x. So x plus y plus z equals 400. And my x I don't know. My y is 150. My z is 50. That means I get 200 equals 400. Subtract, and x equals 200. Okay, so what does that mean? I'm going to get $208 tickets. I'm going to get 50, or I sold 50 $10 tickets. And we sold 100, nope, I wrote that wrong. 150 $10 tickets, right? And 50, there we go, 50 $12 tickets. And there's my final answer, okay? All right, so systems of equations with 3, the key is know what variable you're getting rid of and eliminate it using all 3 of the equations. One of them will get used twice, one of them, the other 2 will get used once, that's fine. And you have to use all equations, so, and then substitute back in to find what you need. So, practice, page 753, 3 through 39 by 3s. Do some practice so that you're not kind of blindsided when you get your first quiz and realize that you weren't very good at this, okay? Practice. Let me know if you have questions.